Right now, deep beneath one of Antarctica's coldest, supposedly safest ice shelves, scientists have discovered a hidden process that could push global sea levels up far faster than anyone predicted. Researchers in Norway just published findings showing that long, narrow channels carved into the underside of the Fimbulisen Ice Shelf in East Antarctica are trapping warm ocean water and melting the ice from below at a rate current climate models never accounted for. This is not happening in West Antarctica, the region scientists have worried about for decades. This is happening in East Antarctica, in a zone researchers have long considered one of the most stable, coldest parts of the entire continent. And the scientists behind this study are saying plainly that the models the world relies on for future sea level projections are missing this process entirely. This is not normal news cycle noise. Antarctica is now doing the one thing scientists warned about for years, quietly destabilizing from underneath, in places nobody thought to watch closely enough. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever seen an iceberg, a glacier, or anything from the polar regions in person? Tell me where you were and what it looked like. Thousands of you have shared stories about ice and glaciers in past videos, and I genuinely love reading every one of them. If you want to be the first to know every time this story develops, subscribe to the channel right now. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm shows it to people who need to see it. Thank you. Now, let us get into it. To understand why this discovery matters, you first need to understand what an ice shelf actually does. Ice shelves are massive floating extensions of land-based glaciers, stretching out over the ocean at the edges of Antarctica. They act like natural barriers, holding back the enormous glaciers behind them, slowing the rate at which land ice slides into the sea. If an ice shelf weakens or collapses, it does not directly raise sea levels itself because it is already floating, but it removes the barrier holding back everything behind it. And once that barrier is gone, glaciers that were previously held in check can accelerate dramatically, dumping ice into the ocean at a pace that directly raises sea levels worldwide. For decades, scientists studying Antarctica focused heavily on atmospheric warming, the slow rise in air temperature affecting the continent's surface. Increasingly, researchers now believe the ocean itself may be playing a far larger role in destabilizing Antarctica than previously understood. The biggest concern involves relatively warm seawater creeping in underneath these floating ice shelves, slowly weakening them from the bottom upward in ways almost impossible to observe directly from the surface. Here's exactly what this new research found. A team led by Tori Hatterman of the IC3 Polar Research Hub and Qin Zhou of Akvaplan Niva, both based in Tromsø, in Arctic Norway, studied the Fimbulisen Ice Shelf in East Antarctica in extraordinary detail. This particular region has generally been considered colder, and therefore less immediately at risk, than the more closely watched ice shelves of West Antarctica. The research team combined a highly detailed map of the underside of the ice shelf with a high-resolution computer model and discovered something researchers had not expected to find there. Long, channel-like formations running beneath the ice shelf were trapping pockets of relatively warm deep water, and those channels were acting almost like amplifiers for heat. Hatterman described the mechanism directly. Beneath the Fimbulisen Ice Shelf, even small amounts of warmer water can substantially increase melting within these channels. As a result, the channels themselves can grow larger over time, and in the worst case, weaken the stability of the entire ice shelf. Qin Zhou added that what is genuinely striking is how even modest inflows of warmer deep water can have an outsized effect when the ice shelf's underside is channeled this way. In plain terms, ice shelves that scientists have long considered cold, stable, and low risk may actually be far more fragile than anyone realized. This finding lands hardest in one specific sentence from Hatterman himself. Current climate models do not capture this effect. That single sentence is the real headline buried inside this entire study. It does not simply mean scientists found a new melting process happening somewhere remote and disconnected from daily life. It means the tools policymakers and coastal planners currently use to project future sea level rise may be systematically underestimating the danger, because they were never built to account for this specific mechanism in the first place. Let us talk about why that gap matters so much. The Intergovernmental Panel on Climate Change has already identified weakening polar ice shelves as one of the largest sources of uncertainty in global sea level projections. Researchers involved in this new study explicitly warned that even regions of East Antarctica once considered relatively stable may now be far more vulnerable than scientists had assumed. That warning is not limited to a single ice shelf. If Fimbulisen has been hiding this vulnerability, and remember, this was one of the specific regions considered safest, it raises an urgent question. How many other ice shelves around Antarctica's coastline might be hiding the exact same hidden channels, quietly weakening in ways nobody has mapped in this level of detail yet? This discovery does not exist in isolation either. Elsewhere on the continent, scientists have already documented exactly what happens when ice destabilization accelerates past a critical point. Hectoria Glacier in West Antarctica retreated roughly 15 miles in just 15 months, a pace of collapse that stunned even scientists who study rapid ice loss for a living. That event demonstrated, in real time, how quickly a weakened glacier system can unravel once its supporting ice shelf can no longer hold it back. The Fimbulisen findings suggest that the specific mechanism enabling that kind of rapid collapse, warm water quietly working beneath the ice, undetected from above, may be far more widespread across Antarctica than researchers previously believed. Let us be honest about what this discovery does and does not mean, because overstating it helps nobody. This study does not predict that the Fimbulisen Ice Shelf will collapse within a specific number of years. It does not claim that global sea level rise is suddenly about to accelerate overnight. What it does establish, clearly and directly from the scientists who conducted the research, is that a real physical process, capable of significantly weakening ice shelves, is currently missing from the climate models the world depends on for future planning. Researchers are calling for ice sheet and climate models to incorporate these small-scale channel features far more realistically, because the current gap has direct consequences for coastal infrastructure planning, for flood risk maps, and for how much time coastal communities actually have to prepare. Here is why this matters, even if you have never been anywhere near a glacier in your entire life. Antarctica holds enough ice to raise global sea levels by dozens of meters if it were to fully melt, though that scenario would unfold over centuries, not years. But even modest, faster than expected contributions from Antarctica can meaningfully accelerate the sea level rise already threatening coastal cities worldwide, from Miami to Jakarta to London. Changes in meltwater entering the Southern Ocean can also influence broader ocean circulation patterns and marine ecosystems surrounding Antarctica, effects that ripple outward far beyond the ice itself. Let us be direct about the practical message here, because information without action is just anxiety. This discovery does not require immediate personal action from anyone watching this video. What it does require is awareness, because these findings will likely reshape how scientists and policymakers approach sea level projections in the years ahead. If you live in a coastal region, staying informed about updated flood risk maps as this research gets incorporated into future climate models is genuinely worthwhile. It typically takes only a few minutes through your local or national coastal planning authority. None of this requires panic. It requires the same thing every major climate finding requires, taking new evidence seriously and updating our understanding as the science develops. Final thought. Antarctica has spent millions of years locked in ice, a continent so remote and so cold that for most of human history, nobody even knew it existed. For decades, scientists believed they understood which parts of it were stable and which parts deserved the most urgent attention. This new research quietly overturns part of that assumption, revealing that even the coldest, most trusted regions of the continent may be hiding vulnerabilities nobody had mapped closely enough to see. The channels beneath Fimbulisen were always there, doing exactly what warm water does when it finds its way beneath ice. What changed is that scientists finally looked closely enough, with detailed enough instruments to actually see it happening. We will keep tracking this story as it develops, every new ice shelf study, every model update, every fresh finding from Antarctica's least watched regions. Subscribe so you do not miss updates on any of it, and leave that comment below. Have you ever seen an iceberg, a glacier, or anything from the polar regions? Tell me what it was like. Because beneath one of the coldest, quietest places on Earth, a process scientists only just discovered may be quietly reshaping coastlines everyone thought they had decades to prepare for. Understanding that is how we stay motivated to take this seriously. 5,000 likes on this video. Let us go. See you in the next one.